Now, after you understood how to use functions that have been defined by others, I guess it's now a good time to better learn how you can define your own functions. I guess there are a number of reasons why you will need it right from the start. There are some very good reasons for learning how to define your own functions right from the beginning of your R career. There are two main reasons for that. First of all, it turns out that although you might not expect that in the first place, that defining new functions actually makes your life much, much easier. It's super useful and often recommendable for a number of reasons I will come back later on. And secondly, and maybe in the beginning that's the even more important part, is that it allows you to better understand how functions work in general. So if you personally know how to define even a very simple function, that makes it much easier for you to understand what happens if you use the function that has been defined by somebody else. And therefore, I guess it's a good place right now here to actually start to learn how to define your own functions. We'll start with some very simple ones, but once you get the fundamental idea, you will figure out that it's actually not that difficult to build upon these basic insights and define more and more complex and useful functions for you. Well, as always, the way you define a function in R is by using a function. And how could it be? New functions are defined by the function called function. I guess the easiest way to understand how this function works is to actually go through an example and just do it in practice. So let's think about a function called Pythagoras that is used to define, to implement the Pythagorean theorem. This theorem, which is incredibly difficult to pronounce for people like me, helps you to compute the length of a hypotenuse in a triangle. And here is how a function definition looks like. So what we do here is a function that takes as an input the length of two parts of a triangle, the cathetus 1, cathetus 2, and uses then the Pythagorean theorem to compute the length of the third part of the triangle, the so-called hypotenuse. And this is just as an example. Think about you get a bunch of geometric tasks where you need to compute a lot of hypotenuses of triangles. So it's something you do all over again, so it might be useful to define a function. First thing you need to think about when you define a new function is actually a name. The name should be insightful. It should somehow give a first idea of what the function does, and it shouldn't be too long. Aside from that, all the requirements for names used in R apply here. So in this simple case, we just call the function Pythagoras, and the name of the function is, as in the case of any object you define in R, the name is followed by the association operator. Then, on the right side of the assignment operator, we start by calling the function, and this function takes two arguments in this case, because the function that we want to define takes two arguments. So we start calling the function, open brackets, and then enter all the arguments of the function we want to define, separated by a comma. Okay, then, most important part, the so-called function body. Here we define the routine that the function should apply on its input whenever it is called. We start so by opening the function body with the curly brackets, and we also close the function body at the very end by the curly brackets. And within the curly brackets, we just write very normal R code that should be executed once the function is applied. Here, very important, whenever we want to refer to the arguments of the function, we use exactly those arguments that we have provided here in the blue part of the function definition. And within the function body, we can refer to the arguments provided to the function call, here in blue, with the respective names. And then This is not strictly necessary, but I recommend you to do it, especially in the beginning. Be explicit what the function should return as its output by using the keyword return and then write the return value within brackets. It's not strictly necessary. If you don't add the return line here, R returns as an output of the function the result of the ultimate line, which in this case here would be nothing because we only have an association. But I recommend you to be explicit, especially in the beginning, using the return statement. So what this function here does, it takes two arguments, cathetus1, cathetus2. In the function body, we can refer to these two arguments by using their respective name. And what does it do? In the first line, it computes the hypotenuse squared by adding the square of cathetus1 to the square of cathetus2. And then in the next line, it takes the result of this computation, computes the square root of it, such that we get the length of the hypotenuse. This is what the Pythagorean theorem actually does. Now, one thing that is very important to keep in mind here is that whatever happens in the function body stays in the function body, except that it is returned explicitly. That means if you don't define cathetus1 or cathetus2 outside the function body, you can't call it. Once you call the function, cathetus1, cathetus2 stay especially within the function body, and they don't go outside. So you can't refer to anything what happens within the function from outside the function. That's actually a good thing, because otherwise things would get very messy. Let's look at what that means in practice. So here's the function that we just discussed. You see, if we define this function, it shines out here in the global environment as an association. So the name Pythagoras, and here the description of it as a function. We can use this function, Pythagoras, here to compute the length of the hypotenuse of a triangle. We say, okay, the length of the cathetus1 is 3, and the length of the cathetus2 is 2. So if we execute this, we now get the result of the length of the hypotenuse. But if you try to call something that has only been defined here in the function body, you will actually get an error. And why is this the case? Because everything that stays within the function body actually stays here. So the definition, cathetus1, cathetus2, or here, hypo squared, they are only defined within the so-called namespace of this function, and they are not defined in the area outside the function. So they are not in what R calls the global namespace. This is actually very useful, because otherwise your global namespace here, what you see above here, the global environment with all the without the object name associations, would be completely messed up, especially if you write a couple of functions. This can be dangerous, however. If you, for some reason, define an object called hyposquared with the same name as the object within the function, you might get confused. So you execute the function. Here, hyposquared within the function is used as a name for this, what happens in this line. And if you call hyposquared, you do not get the result of the computation here within the function, but what has been defined outside the function. Even if you then again execute the function, if you call hyposquared, you still get the object that has been associated with this name outside the function. There can be situations where this can be confusing. So it's very important to keep in mind that everything here stays within the function body, or what happens within the function body stays within the function body. And the only thing that actually leaves the function is what has specified here in this line alongside the return statement. Now that we have introduced the basics of how to define a function, let's do an intermediate exercise. So your task would be to write a function that computes the daily interest returns and that takes 3 arguments. These arguments should be, first of all, the interest rate, but expressed as an annual interest rate, because that's what you usually get, the size of the initial investment, and the length of the overall investment activities in days. And then you can use the following function here, or formula, to compute the daily interest payments or daily interest returns. Here, maybe keep in mind the example that we've discussed before. Maybe this is helpful. Your task now is actually to just write this function and apply it to one or two examples. And we will take this example later on to add some more features like function documentation, etc. But here, it's really just about the basic idea.